Welcome to this webinar on interface management with SysML. In the next half hour, I will explain why interfaces are important, why model-based systems engineering and SysML are well suited for mastering interfaces, why many stakeholders reject formal specified interfaces in spite of their usefulness, and how we can overcome this and excite our peers regarding model-based systems engineering, MBSE. I'm going to show you some simple approaches on how to harvest the low-hanging fruit, how to make your MBSE initiative more effective with little effort. A few notes on logistics. Your microphone will be muted, but you can ask questions by the Q&A chat. So let's get started. Why are interfaces important? Well, one key aspect of interfaces is that they are the foundation for proper assembly and integration. And in practice, for many complex systems, integration is the place where things blow up. A lot of delays happen, things just don't fit together. And if you have ever self-assembled furniture, and if you ever encountered a hole in the wrong place, you know what I'm talking about here. Except in the old days and with mechanical systems, integration is fairly easy and straightforward. But with with more complex systems that consists of hardware, software, mechanics, electrics, this is a real problem. I just get a message here that someone is getting an echo on the audio. If anybody else is having an echo, just please give like a quick note in the question and answer section so that I know whether it's just one person or whether everybody is having a problem. Thank you. No echo or somebody else. So John, sorry, I think it must be on your side. So this is the reason why interface management is a huge issue. In the old days, it was fairly straightforward. Today, we have to deal with integrating mechanical components, electrical components, and on top of that, we have more and more software in our systems. And I just want to give you like a super brief, simple example that everybody knows, the good old USB plug. And there we have like all three layers that we typically have to deal with. First of all, the plug has to fit the different standards. So you immediately know whether there's an issue with connecting it mechanically, but that's not enough. The next level is the electrical level. And you might have encountered a situation where you wanted to do some fast charging. It didn't work because the cable simply didn't have the wiring. The third level is on the protocol level, the software level, and some cables and some systems can negotiate to, for example, transmit video signals, but not every system can do that. And here we're talking about a standardized interface. In most cases, we design our own interfaces so that we can effectively build a system that consists of many, many subsystems and assemble it with confidence. I want to give you an example from the automotive industry, which is currently under enormous pressure on delivering better products faster. And the automotive industry is realizing that interfaces are key to success. And these interfaces in the automotive industry manifest in the form of a platform. And here you see an example, the Volkswagen platform for building electrical cars. So Volkswagen is betting on this. They managed to already reduce the time to market by using this platform approach. And it's fairly visible. We see the mechanical aspects of the platform. We also see like a little bit of wiring, but in practice, the single biggest challenge is the software layer. So this is what I wanted to give you to set the stage. Today is about how we can harvest the low-hanging fruit of better interface management for making sure that integration doesn't create problems and to speed up the time to market. So here's what you can expect today. So we're going to start to talk about the impact of interfaces on product integration. I just did that. Next, we're going to talk about modeling with SysML, which is the most commonly used modeling language for model-based systems engineering. And we are also talking about the important aspect of really making interfaces available to stakeholders. This is key because unfortunately, acceptance of model-based systems engineering is not as high as it should be. All right, with that, let me just give you like a super quick introduction on myself. I'm Michael Jastrom. I've been working with model-based systems engineering for over 15 years right now and in product development for much longer. I'm focusing on helping organizations to speed up product velocity to getting faster to market. And if you're interested, check out my weekly blog, SE Trends, where you can get information on systems engineering in German and in English. This webinar is organized by Sodius Willard, who is a global software tool vendor and building solutions on top of existing tools to make them more effective, including the tools from IBM like Rhapsody for model-based systems engineering and others. And Sodius Willard is focusing on highly regulated industries like automotive, but also many others. And so why do we practice model-based systems engineering? Well, it's to master complexity, and complexity has been exploding for the last 20 years. In the old days, we had to deal with mechanical and electrical systems. Software systems tended to be small, not anymore. Now, thanks to software, networking, complexity is exploding. By having more complexity in products, compliance requirements are rising, team sizes are rising, which again, in turn, leads to more complexity. And model-based systems engineering is one approach of mastering that and of managing that complexity. And one key idea behind model-based systems engineering is to define clear boundaries of your systems and subsystems and to establish a black box thinking where you think of your systems as black boxes that do something, but where you do not need to know any of the details of the implementation. And here you see like a super simple example. You put energy in, you get light out. That's a regular light bulb. And the nice thing is that if you need a light source, that's all you need to know. However, if you're providing the light source, then you need to implement it. And there are many different ways for implementing this. The good old light bulb, but you can also have an LED, or you could even tack on some additional functionality to your black box that you provide to customers. And you do not have to know in which context this system, the subsystem, or this component is being used. But again, due to the increased use of especially software, complexity is exploding here. So what exactly is an interface? We're talking about interfaces without defining them. Here is one possible definition from the ISO standard 24748. And to sum it up, it's the point where system elements meet. That's a very simple definition of an interface. But the devil is in the details because you not only need to specify the mechanical connection or the currents that are running, but also behavior. What are you expecting? Are there any protocols? So there are lots of subtleties. Managing interfaces is not really new. This has been done for decades. But in the old days, we used to do that in a document-based approach with an interface control document, or ICD for short. And again, this actually works quite well if the processes support it. The problem with interface control documents is that you have significant overhead because everybody has to read these. Changes are tedious to propagate. It works, but it doesn't scale. That's the bottom line. In practice, however, you might wonder whether it even works that well, because in a typical organization, you have the heterogeneous environment of your tools. So maybe the software development team really likes to put documentation into Confluence, but then some other departments prefer to communicate with Word. If you have your information in the form of tables, then you might also have Excel spreadsheets flying around and everything is getting out of date. And last, even though we are in 2025, we still have PDFs um, floating around everywhere, which are even harder to digest and to use for traceability and other typical activities. So how to solve that? Again, I already mentioned MBSE a few times. In the following, I want to use a simple example from the automotive domain, which I'm going to show you in Rhapsody from IBM. And so the example is a simple idea, a, well, let me start it again. Um, a driver assistance system that adjusts the speed according to traffic and a set speed. So, and then everybody knows that most cars have that these days. And the nice thing is that if you use model-based systems engineering, that you can even see this black box concept. So here we see the SysML block, the functional view of our ADAS, and you see that it has a number of ports. These are SysML proxy ports. Some have a little arrowhead in it indicating the directions, others don't. And they all have a name and more importantly, a type. And so one of the big advantages of model-based systems engineering is that the modeling tool can ensure compatibility of interfaces as you integrate your tools, your blocks into your overall system. And it gives you the ability to reference elements. So it's much easier to deal with change. And again, it supports this black box, glass box thinking, where this is the black box view, but the engineers working on the actual implementation, they can then use the modeling tool to add more implementation details or design details to the system overall. And for those of you who are using that in the organization, of course, you need a methodology for this to work. And so typically we also introduce various layers like the problem layer, functional layer, the technical layer, and so forth. And the tools support this kind of work. Let's now have a quick look at how this looks in a modeling tool. So I have Rhapsody open here for those who know it. It's the SysML modeling tool from IBM. Here we see the system context where we can see all the various stakeholders who interact with our ADAS system. We can see the parts that it has, but it's a black box view, which we can penetrate by looking inside and following the model. And again, what's important here is, and most of you probably know that, this is not a picture, this is a view on the model. So we have a model tree on the left, which has all these elements, allowing us to reference them multiple times, allowing the system to check for compatibility and other issues. And I can drill down as deep as I want to. So using MBSE and SysML for systems modeling has a number of benefits. There is a clarity that you simply do not get from plain text. You can detect issues early. You see if there are incompatibilities. This reduces risk. There are a number of use cases that require detailed traceability, for example, for compliance. Reuse is another big benefit. What we saw earlier, the platform approach from Volkswagen allows the reuse of the platform for many different vehicles and so forth. So there are many benefits, but there are also disadvantages. Besides the fact that you need a certain time to ramp up and to get to a point where you can actually be productive, there's also the issue of acceptance. And this is one of the key topics at today's webinar. How do we get acceptance? There are a number of stakeholders that need to access your system architecture, from requirements engineering to the testing team configuration, but also non-technical groups. There's project management, there's portfolio planning, there's suppliers and external partners, marketing management, and so forth. And not everybody has this high tolerance for formal specifications and the use of a dedicated modeling language. And so what you can see here is that some groups are rather impartial, like requirements engineering or the testing group, but some are rather, not that excited about, like project management, certainly marketing and leadership very often have a certain resistance to even deal and interact with these. But these are all important stakeholders. We do not really have to get everybody on the same page. But at the same time, it's important to lower the barriers. One group I want to briefly talk about, the engineering disciplines. They're usually the ones that are the most open because they see immediate benefits of working with the model. For example, by processing parameters coming from the model. But generally, it's important to really make sure that all the stakeholders who have a stake in the model have access to that. And in practice, if we replace our interface specification with a model in Rhapsody, then some groups are excited about that and some others don't accept that and simply ignore it, which often leads to duplicate work and delays, outdated information, and so forth. So how can we break up the silos between the various stakeholder groups? That's kind of the question. And again, if we really want things to not blow up during integration, then the interfaces are a key aspect of what we need to communicate to other stakeholders. And so that's the key idea, that we need to speak the stakeholders' language. And this is where I want to give you a second tool demonstrations showing you how the add-ons from Sodius Willard can actually help you generate documentation that is fit for consumption for some of those stakeholder groups. There are two different tools available. The ICD generator uses the IBM publishing tool, which has the added benefit that you can also pull in data from other sources and you have like a lot of flexibility on the appearance. And this is also something, because you can generate PDFs, that you can share across organizational boundaries, which is quite helpful because typically the firewall of a company is something where you wouldn't want to penetrate. The other is the HTML generation, where you generate static HTML that you can put on an intranet, but which you could also, for example, through Portal, provide your suppliers with. So let's have a look at how this looks in action. For that, let me just go back here to my tool. And we have another palette up here with the Power Pack from Sodius Willard tools. But if I would want, for example, for my functional analysis, create an export of the ICD, I'll go here down to the Power Pack and have the generate ICD menu here, which will then provide me with a PDF document when it's exported that contains the visuals, where I can see my system overview, but also lots of the information in tables that is fit for processing by the receiving end. And a lot of stakeholders who are used to working with traditional ICDs are very familiar with this approach of working. The other benefit here is that it might actually make stakeholders curious and they might reach out to you to find out how they can maybe work in a more direct way with your model and interact with it. And as this can always be generated on demand, of course, it has to be aligned with your configuration management and version management. You'll be able to generate that at any time. The other approach is to generate HTML. So again, we go to the Power Pack where we have some reporting tools here and we see the ICT generator. And this one actually generates HTML, which is right embedded into Rhapsody, as you can see as a separate tab, where I can see an overview of my diagrams and also a list of all the interfaces that I have. And as you can see here, it says locate in Rhapsody. If I have Rhapsody open and installed on my computer, I can jump directly to the right place in the model tree. But again, this is also usable outside Rhapsody. This is just static HTML that I can put on an intranet or even on a vendor portal where other stakeholders can access it, where they can then look at the topic of their interest, follow the various links, and just use it like a website where they can get the information that they need. And again, at some point, they reach a point where it have to jump into the model. If this is shared with an external party, they can, of course, not jump into your model. So there's like a clear separation where you can make sure that confidential content is not accessible. So if we have these kinds of fairly simple but straightforward tools and start to implement them, we'll suddenly be able to prevent this situation. And those stakeholders who were excluded before, we can now reach by giving them indirect access to the model, either via Word export, the HTML that is interactive, or an exported PDF. This allows you sharing both internally and externally. So these are the benefits of interface management. You have few integration surprises, you have improved collaboration, and many other benefits, in particular regarding compliance, like ISO 26262 or ASPICE compliance. But of course, this is not a full solution in itself. You really, really need a bigger picture and vision for your model-based systems engineering in order to really be successful and to make a quantum leap in productivity and being able to master complexity. This is very important. And again, just to give you an idea of what I mean by that, you really, really need somebody with a vision who has a clear vision on what MBSE can actually achieve. And you need to communicate this vision really top down. And of course, when you try to impose things on people top down, you can easily hit resistance. That's why it is so important to complement that with a bottom up approach where you have small victories, where you have like small achievements that provide some tangible value to encourage people to continue to push on and to also provide some feedback that the vision is moving in the right direction. And this is not a two-step process. You have several steps. So they're like smaller ones. And what I just showed you, having a clear understanding of what the benefits of interface management are, how this can be realized and modeled with a proper MBSE approach, and then provide your stakeholders with the tools of making these interfaces accessible, that would be like such a tactic that would really help your stakeholders to really get interested, to request more, and to get really, really excited about what you're doing and building better products faster. So again, like this is all I wanted to share with you today. There's a lot of information available Sodius Willard and myself, we are more than happy to help you on this journey to complement the ideas with some practical insights on how to get there and how to make it happen. And so with this, I want to conclude the webinar. And please use the Q&A box for questions that you might have. And I already have a few questions lined up here. So let me go right over in the Q&A session. So the first question that I'm seeing here is, what about other tools? And yeah, I showed Rhapsody here, which is one possibility. But of course, every modeling tool out there has some kind of reporting mechanism which you can use for realizing that. What's interesting here is that with the Power Pack that I showed, you have additional options. And the more options you have, the higher your chance of talking to your stakeholders. But yeah, basically, you can implement this approach with any modeling tool that provides you with reporting capabilities. The next question I have here is, and that's an interesting one, SysML v2. So just to make sure that everybody is on the same page, what I showed just now in Rhapsody is SysML version 1, which has been around for, I think, 10, 15 years now. And we just got last year version 2 released, which is actually a huge change to V1. In fact, the change is so big that most tool vendors, including IBM, decided to build new tools for this rather than just upgrading the existing tools. So for example, IBM just released Rhapsody SE, which is a SysML v2 only tool. And yeah, SysML v2 it has a number of really interesting improvements that are relevant for what I showed you here. Number one, it provides an API. So that means that you can access your model and extract the information that you need for interface sharing through the API. So this is definitely a big benefit, which opens up more possibility. SysML v2 also has a textual representation, which almost looks like software code. And this is something that is particularly interesting to technical teams because they feel more at home sometimes with textual representation of models rather than with visual representation. It's also easier to process if that's what you want to do. So that's SysML v2. And for those interested in SysML v2, I encourage you to check out the Rhapsody SE tool as well. So do we have any other questions? Yes. I have another question here regarding methodology. And I didn't talk about methodology here at all. So there are a number of different methods around. Well known is OSAM, which the INCOSE group has a working group for. There's also a book on that available. And that's a fairly widely used method, which is compatible. Same with Harmony or SysMod, if you heard about those. What all these methods have in common is that they typically have this layered approach where you start with the problem view, then you have a black box or a view. You typically have like a functional view and then a technical view, so that you have like this decomposition from top to bottom. And so the question is, at what level do you really need to share interfaces and where do you get the biggest benefits? And what I've seen is that number one, on the architectural level, that's where people really benefit from having a clear understanding of interfaces and on the technical level. So those are the two levels that I've seen most people talk about. Um, let's see. I have another question on, um, oh, interesting. Yeah, integration with design, CAD or simulation and other approaches. Yeah, this is actually quite interesting because, yeah, we can, if we want to have, say, your CAD design be based on your system model, you can export a document, but you can also directly access the model, for example, via OSLC, which is a technology, an open technology for integrating lifecycle artifacts. And if your CAD program is parameterized, then you can, for example, use parameters from your system model, from a parametric block, for example, and delegate that to the CAD system to feed into parameter. This is fairly sophisticated, and very often the cost is too high for the benefits, but it's something that certainly is possible. I see another question here about Rhapsody. I'd like to know what is the constellation of apps programs needed to run together with Rhapsody? I'm very used to work with stores. Is that, for instance, included in Rhapsody? Um, yeah, that's actually a very good question because tool ecosystem is one of those super big and super important questions. You really need a tool ecosystem that allows you to integrate all your tools so that you don't have that many silos. That's really what you want to prevent. And the answer is, so that the basic technology that IBM developed for that is called JAS. And so I'm not sure whether you're using classical doors or Doors Next. Doors Next is based on JAS. And oh, I just see it's classical. Yeah. Yeah. So Doors Next is based on JAS, which also implements like this whole OSLC ecosystem. Doors Classical, I have to admit, I believe is much more tricky. I believe they also have an OSLC integration by then, but that is basically what IBM recommends as the platform for integration to using JAS and then using OSLC as the integration technology. And just to be clear, OSLC is an open technology. So other tools from other vendors very often these days also have OSLC gateways. So yeah, that was definitely a good question because that is a huge issue with respect to breaking up silos. Any other? Yeah, there's one more question about talking about other ways for getting stakeholders pulled in, specifically dashboards. Yeah, this is actually a good question. As far as I know, you have like a number of standard reports, but that's not the same as having a dashboard. Um, there is, as far as I know, no ready-to-use dashboard technology that you get out of the box. But I've seen organizations that used OSLC quite effectively for creating dashboards and other technologies. Again, like one of the ideas behind OSLC, just to very briefly describe that, is that you have a standard approach of accessing artifacts from other tools like requirements, like model elements, so that you do not duplicate content, but that you can actually access them in real time when you need them. And so along those lines, for example, if you have a dashboard and you want to get certain information, you can simply propagate your OSLC tree in order to update your dashboard by pulling together data from the various tools. I got another question here. Is it possible to change the template of the shown PDF? Yes, of course it is. And then that's one of the reasons why here we used IBM Pub, so the publishing platform. So Pub is actually not just, utility, it's really a publishing engine that allows you to pull data together from multiple places in a relatively user-friendly fashion. So you ask here for an easy edit page. Um, Whether it is easy or not depends on the depth of your reporting. So changing the appearance or including a filter for only seeing certain content, that is straightforward and that's fairly easy. But if you, for example, want to get like some really complex logic that processes data in a certain way, yeah, then of course you'd need like a little bit of scripting or programming capabilities in order to do that. So I hope that answered that question. Are there any other questions? I'm now at the end of the Q&A question lists. I hope that was useful to you. And again, what I showed from PowerPack was just this one functionality. And if you've seen from the context menu that I had opened, there are like dozens of little utilities in PowerPack that make your life much, much easier. And it's often these little victories that really, really help you to gain the trust of your stakeholders and really moving your MBSE initiative forward. If there are no other questions at this point, then I really thank you for joining today. I hope you got some inspiration out of that. And if you want to have additional resources, just reach out to myself, to Sodius Willard, and I would also love to see you at one of our future webinars. All right, enjoy the rest of the day. Thank you for your time.